Right, this lesson's on the motion of a particle in a straight line. When we're looking at motion of particles, we used to consider distance and speed. Speed equals distance over time. But it's really not sufficient to consider those. They are scalar quantities because they don't take into account the direction that the particle's moving in. So rather than that, we now use some different quantities, which are vector quantities. And the vector quantities that we use are, the first one is displacement. And that's a bit like distance, only it takes into account the direction that you move in. And the letter that we give to that when we're doing this is S. The vector quantity that we use for the speed is called velocity. And the letter that we give that is A. And the final one that we use is acceleration. And that is an A. What we know is that velocity is the rate at which displacement changes over time. Now hopefully that rate of change of something will ring a bell with you, and it's what we've just been doing in lessons, all this differentiation. And what that's saying is that the velocity is ds, the rate of change of displacement, with respect to time, dt. So that is how we find the velocity, ds by dt. We differentiate the displacement. And the acceleration is the rate of change of velocity with respect to time. So that's how the velocity changes over time gives you your acceleration. Your acceleration is all to do with how your velocity is changing. And that means that we can use A, acceleration, is dv by dt, the rate of change of the velocity. So if these are our three quantities, displacement, which is s, velocity, which is v, and acceleration, which is a, if those are our three quantities, then when we're looking at changing between the three, we say, well, I know that the velocity is ds by dt. So to get from the displacement to the velocity, we differentiate. And I also know that the acceleration is dv by dt. So to get from the velocity to the acceleration, I differentiate as well. So let's do an example to see how this works. So the velocity of a ball, v meters per second, after t seconds is given by this formula, v equals 8 plus 10t minus t squared. And first of all, we're asked to find the acceleration of this ball after t seconds. Well, we know, or we should know, that the acceleration is just the differentiation of the velocity with respect to t. So if we look at above, if we differentiate this v, we'll get the 8 will be nothing, the 10t differentiates to become 10, and the minus t squared differentiates to become minus 2t. So that's part A. That is my acceleration after t number of seconds. Part B asks us to find the acceleration, or work out when the acceleration is 0. So when the acceleration is 0, we're asked to find the time that the acceleration is 0. Well, if this 10 minus 2t is the formula for acceleration, if we want to find when that is 0, all we need to do is solve this equation. So 10 must be equal to 2t, so t must be 5. So the acceleration is 0 after 5 seconds, or when t is 5 seconds. And for part C, we're asked, or hence, which gives you a clue that you're probably going to use something from one of the parts before, find the maximum velocity. So the maximum velocity is going to happen when dv by dt is 0. But we know that dv dt is a. That's what we've just worked out. So the maximum velocity happens when a is 0. Your acceleration is 0. And we know that from above, and we know that that happens when t equals 5. So we know that a equals 0 when the time is 5. And we just want to find the maximum velocity. So if I know that the velocity is 8 plus 10t minus t squared, when t is 5, that velocity will be 8 plus 10 times 5 minus 5 squared. So it will be 8 plus 50 minus 25, and that gives you 33 meters per second. So the maximum velocity that the ball reaches is 33 meters per second.